Hi Trig. Well, good morning. You guys are getting ready to come in here in about 15 minutes, but I'm going to knock out a little activity thing that I want from you guys, a little poll, if you will. We have this election coming up, and we all should vote because voting affects change, and change is a good thing. Change is scary, but change is a good thing. So what I want from you guys, I am about to show you two different ways to answer the question, how many radians are there in a full circle? Okay, whether you understand it or not, I want you to understand it, but I'm going to show you the two different ways. I've kind of always thought about these two ways and wrestled with which one to show you guys. So I'm going to show you both of them right now, quickly, a little synopsis, and then you're going to take a little poll and vote which one you think is better. You are affecting change. You're going to vote on this, and then moving forward for future generations of trig students, you're going to decide which method I teach in the future. All right, here you go. How many radians make a full circle? With the string and with that worksheet I had you guys do, this was what I was getting at. So hopefully you got this. We made two statements. The first statement was, after I gave you the definition of a radian, we could say a full circle is a certain number of radians. Okay, made a little math equation from the word equation. Next, we did some words and figured out, well, a full circle is the same as the circumference of a circle. And the circumference of a circle is 2 pi times the radius. Based on our definition, the number a radian is every time that we get a radius, these are the same thing. A full circle is the same as a circumference. Those are the same thing. Which leaves me with what we were looking for. The number of radians needs to be 2 pi. It is 2 pi radians around the full circle. So we took some liberties there, but that was what the general idea was. That's option one. Option two is to say this. If I have this long piece of rope, and I'm going to call this rope FC, just because I feel like it. And then I'm going to have this little smaller piece of rope called R. I would say, well, the question is, what would I need to do with these to figure out how many R's would fit on FC? How many of these things fit on FC? And hopefully you guys came up with, well, we would divide them. I would say that the total divided by little piece would tell me how many of the little pieces. So FC divided by R would give me the number of R's that fit on there. Okay, and then it's just a little walk across to say, well, if I just took that piece of rope and turned it into a circle, and I have this R, which represents the radius of my circle, every time I lay a radius around the outside of my circle, I get a radian. One radius, one radian. 2 radii, 2 radians. 3 radii, 3 radians. And so on and so forth. So now the question becomes, if I have a full circle, FC, how many of these little R's would fit around there? Because however many little R's fit around there, that's how many radians we have. So it's kind of the same thing, huh? If I have a full circle, that's 2 pi R. I'm dividing by R, and that gives me the number of radians. The R's cancel, and on a full circle, the number of radians is 2 pi. 2 pi radians. So we had two ways of thinking it. I mean, they're pretty similar, but this was kind of the string method that we did, making the two equations. This one was talking about how many of these fit on this and going straight to division. I'm going to give you guys a little poll. Affect some change today. Go out and vote. Make it happen. All right, moving on.